Okay, we're going to take a look at what happens when we get a set of equations, a set of three equations with three variables that does not have a unique solution, so that we throw them into our calculator and we basically get an error message. So there's two situations of, there's three situations. We're going to look at inconsistent system of equations. So inconsistent means that basically we have no solution, and graphically it looks like one of these three situations. So when we do it in two dimensions with lines, basically you can see that the lines here are parallel, so they'll never meet, and so that there can be no point of intersection between those two lines. Basically that happens with the planes as well, right? So three planes are parallel, or two planes are parallel and the third crosses through them, or another situation which we'll get into graphically as we go. So when we have an inconsistent system of equations, we get no solution because there's no point where all three planes intersect, because there's a parallel situation here. And then we must identify which, if it's inconsistent, and then what situation that we have. Is it all three planes are parallel, which is the easiest one to identify? Is it two planes parallel and the third is not? Is it one where we get this strange kind of thing happening where the planes themselves aren't parallel, but the lines where they intersect between them is parallel, which is a toughie. So we're going to take a look at the first situation and I'm just making a video of the first situation. So inconsistent where all three planes are parallel. So when you see a system of equations, you should label them 1, 2, 3, and then determine what kind of situation that you have. So the first port of call would be to throw them into your graphing calculator and see if you get a solution. If you don't get a solution, then you have to determine what you have. So what you do, this is what it would look like graphically, but let's just play around with the numbers, right? So if we play around with the coefficients that are in front of the letters, so in this particular first equation, the coefficients in front of the x are 1, and in front of the y is 1, and in front of the z is -1, and then we have our constant, right? This is our constant, 10. So these things here are called coefficients. And they will determine whether whether systems of equations are parallel to each other or not. And it all has to do with ratios. So if we take a look at the coefficients in relation to each other. So let's just take a look at, first of all, let's just take a look at equations 1 and 2 and their coefficients. Now, if we look at the coefficients in front of those x's, we get a 1 to 2 ratio. And if we look at the y coefficients, we get a 1 to 2 ratio. And if we look at the z coefficients, we get a -1 over a -2, which is exactly the same as 1 over 2. And then if we look at the constants, we see that the constants don't work. They're not a 1 to 2 ratio. They are not proportional, okay? So what we have is we have this situation here, where we have the ratios of the coefficients of equations 1 and 2 are 1 to 2, 1 to 2, 1 to 2. They are equal ratios. But excluding the constants, right? The constants aren't in proportion. So we have to test that. So what that tells us is when we have this kind of situation, equal ratios, but not the constant, we'll get us a pair. So that basically tells me that these two equations here are parallel to each other. Now we want to check to see if all three are parallel to each other. So let's check 2 and 3. So we've checked 1 and 2. Let's check 2 and 3. So 2 and 3, if we take a look at the coefficient ratios, if you take a look at what's in front of the x's, we get a 2 to 3. And then in front of the y's is a 2 to 3. In front of the z's is a -2 to a -3. And then we take a look at the constants, and we get a 3 to 8, which is not equal to these. But these are all 2 to 3, 2 to 3, 2 to 3. So what we have just discovered is not only is one and two, equations 1 and 2, the planes parallel, but 2 and 3 are also parallel. So that means all three planes are parallel. You don't have to test all three, because if 1 and 2 are parallel, 2 and 3 are parallel, then all three are parallel. So you have graphically this kind of situation. So if we bypass the algebra, the statement that you would have to make at merit level is, first of all, you have to realize that what you have just worked out is the fact that you have no solution and an inconsistent. So all three planes are parallel. We've just discovered that through their proportions or the ratios, right? Proportional. The ratios are proportional. And the constants are not involved in that. Constants not. All right, so when you have all three equations have coefficients that are proportional, but the constants are not, then you have an inconsistent situation. Right? So your statement has to be this: all three planes are parallel to each other because they are parallel. They have no unique solution. They are inconsistent. And instead of saying no unique solution, we can just say no solution. Now, there's more that needs to be done in an excellence capacity. We have to do some algebra. But at merit capacity, if we can identify what the situation is using just the proportional thinking along with the constants, that we have an inconsistent situation, we have three parallel planes, they have no solution, then that is a beginnings of what